Okay, hello guys. In this video, we are going to learn about the crop suitability analysis using Arc GIS. So, in this video, I have already provided you the required layers for the cropland suitability analysis. So, the study area is Lamai, which is one of the place of the Dang district of Nepal, country Nepal. So, this is the shape file of the Lamai municipality. So, I have provided it. If you want this data, you can click on the link given in the description below and get all these layers ready for you. So this is Lomé, and let's say this is the slope uh, already calculated so that it will be easier for us, so that we will focus on the main topic. And this is the elevation. Okay, this is the land is land cover that is done by the supervised classification, and this is the soil moisture. So soil moisture is obtained by using the NDWI, normalized difference water index. So it is related with the soil moisture. So this is the road shape file of the Lomai municipality, as well as this is the aspect, and this is the river of the Lomai municipality. So let's do our work. Let's at first do the multi-ring buffer for the road and river. So in which distance we are going to do buffer, I have given you a PDF. You can also download it from the description below. So here I have given the criteria and their weightage and the influences, that is in percentage, the same percentage in term of percentage, weightage in term of percentage, and the sub criteria and score or rank. So uh, this is the criteria for the river. We are going to use this 0 to 0.5 means 0 to 500 meter, and 500 to 1 kilometer, 1 to 2 kilometer. By this way we are going to do multi-ring buffer for the river as well as for the road. We are going to use the sub criteria this. So let's do. Okay, for multi-ring buffer, go to analysis tool and go to proximity. You can see here multi-ring buffer. Double click on it and you can see here. Okay, let's select a feature. Okay, let me select the road. Before that, I request you to make a database. So let's close it and let's create a database. Okay, let's go on catalog and let's create a. Okay, here it is. I will create a database here. Okay, okay, let me create a geodatabase. Okay, I'm going to create a file geodatabase. Okay, let's rename it. Okay, I'm gonna rename it as Cropland, and let me make it default so that it will be easier for me. Okay, this is the road. Now let's go to multi-ring buffer. Okay, click on it. Okay, drag the input feature here, or you can choose the drop down button also. So here is the road multi-ring buffer, because I've already set default geo database, so it is here. So let's do multi-ring buffer. Okay, as I have already shown you the sub criteria for the role, this is like this. I'm going to use this one. So this is 0 to 500, so 500 will be break value and the buffer unit will be meter here. Okay, now let's edit. Okay, then after 1 kilometer, that is 1000 meter. Okay, now edit. Okay, then after 1500 meter. Okay, then after 2000 meter and 2500 meter. Okay, we have this. Let's do multi-ring buffer. Click on OK. So it is being loaded. If not shown here, you can go to geoprocessing and click on result to see the activity that is being carried on. Okay, let's go to results. So here you can see current session and multi-ring buffer is being carried out. Okay, let's wait for some minute. So we can see here multi-ring buffer for the road has been done. So this is multi-ring buffer. Okay, now let's similarly do the multi-ring buffer for the river. Okay, this is the river and the distance are given here on the PDF file, so you can see it. Okay, and let's do. Okay, the buffer is like this multi-ring buffer 500 meter, and then after 500 meter there is 1000 meter and 2000, 3000 and 4500. Okay, and let's click on OK. So you can see here the multi-ring buffer operation being carried out. If it is not shown here, you can go to geoprocessing and result and see there in current session. So now we can see the river also multi-ring buffered here. So now our next task is to convert this polygon into raster. For this, let's go to conversion tool. Then after, so we are going to change from the polygon to raster. So go to raster menu, and then you can see here polygon to raster. Okay, select the polygon, and in the value field we are going to rasterize it by using the distance. So click on this distance, and then we're gonna choose here river vast. Okay, we have done buffer. Okay, let's do this. And okay, let's to check the default database. Okay, read rust buff. Okay, so make habit of saving the file in the geo database. So this is the raster file. Okay, and now let's do polygon to raster for the road that is multi-buffer. So do this, the distance same way as previous. Okay, now road raster buffer. Okay, now click on OK same as previous. Okay, we can see here road and river that is multi-ring buffer is now converted into raster file. So let's remove these unnecessary layers. Okay, the next task we are going to do is extract the raster file inside this boundary of the domain. So for this we can go to special analyst tool, and we can go to the, so here might be some extraction and extract by marks. Okay, uh, let's select the input raster road buffer, that is multi-ring buffer, and the llama. Okay, and so let's rename it. This is road. Okay, road uh, mask. Okay, and let's click on OK. Okay, is being shown. Okay, let's do the same for another one. This is for river. Okay, okay, input raster, this will be Lomai, and this is okay, let's do okay, river mask. Okay, now let's do this. Okay, we can see here the river mask. Okay, these two data are unnecessary for us now. Let's remove them. So this is the shape file or the layer for the river and the road, that is multiring buffer and converted into raster, and then that is extracted inside the domain. So now our next task is to reclassify the layers. So uh, at first let's reclassify the slope. For reclassifying, we are going to use the same PDF well, I have given to you. You can download it from the description uh, below. Okay, we are going to classify them on this way. Okay, we are giving this criteria and also giving this score or rank. Okay, you can do it by comparing or looking to this criteria and rank. I am using the dual monitor, so I am going to move in another screen. So if you want to reach class, so you have the reclass tool in special analyst. So you can go to reclassify. Okay, let's select a raster file, that is slope, and reclass field, that is the okay, that is default value. So the slope value are stored in the value field, and let's reclassify. You can see here 1 2 3 4 5 sub criteria. Let's use the number of classes 5 and break values as 3 10 20 30 and 89, or the maximum 1. Okay, let's click OK. Then let's give the value. So we have seen here in the PDF for 0 to 3 it is very best for the agriculture, so we are going to give this score or rank 10, as we the rank starts from 1 to 10. For 1 is the least suitable and 10 is the more suitable. So as per the PDF given, we are going to do this. Okay, okay, so okay, output raster file will be saved on the Cropland database. Reclass slope, okay, this will be better. Okay, I click OK. So the layer has been ready, and the next one is the slope. Okay, let's reclassify. Sorry, the next one is the elevation. Okay, let's do the same thing that we have done. Okay, the value field is value, and let's classify in elevation. There is also 5 classes. Okay, and the break value is 150 and 500,000. Okay, there will be 800 and more than this. Okay, so let's give the value as per the PDF. Okay, now let's click on OK. So we have reclassified the elevation also, and then we go with the LLC. For LLC, let's reclassify it. It is a bit different. Okay, let's select LLC, and we don't need to reclassify them because we have assigned as a water bodies, forest area, settlement, and barren. Okay, in the PDF you can see for agricultural land it is 10, and for the settlement it is 1, and for the water bodies, okay, it is 1, and for the barren land it is 3, and for the forest it is 1. Okay, let's rename it. Okay, reclass LC. Okay, let's click on save. Okay, now our another reclassified raster file is being prepared. So the next one is the soil moisture. Okay, let's reclassify the soil moisture, that is, the reclass field is value. So let's reclassify it. Okay, similarly there are also 5 classes. Okay, and the break value is uh, in percentage 0.15. Okay, it automatically changes its value, and 0.2, 0.25, and 0.3, and greater than this. And let's click on OK, and the value are like this. Okay, if you are thinking about the how I get this value, so I got this value by the literature review from the different articles. Okay, okay, now distance from river is to be reclassified, then after aspect, and then after road. So I'm going to do it. Okay, let's reclassify the distance from the road. So this one is on here, what it is. Okay, distance from river. Okay, we are going to reclassify on the basis of value. That value is the distance. Okay, if the river is near, then it is more beneficial. So the more near is given the high value. Okay, 10 for the up to 100 meter, 1000 meter, that is 7, this is 5, 2, and 1. Okay, let's save it, and let's similarly do for the road also. Okay, for road mask. Okay, on the value. Okay, similarly let's do it. 10, 7, 4, 3, sorry, and 1. Okay, that is also reclassified. And the next one is the aspect. Aspect is a bit different, but it is not that hard. So let's reclassify the aspect. Okay, where is aspect? Okay, this is aspect, and this, let's reclassify on the basis of this value. Okay, okay, this value is the flat, so this value is given the value of 10, so the flat value is more important, and minus the, so this value up to 22 0.25 is north, and north is given the value 1, and 22.5 to 67.5 is the northeast. For the northeast it is given 3, okay, and the 67.5 to the 112.5, that is east, and the east is given value the 5. So and the 112.5 to 157.5, that is southeast is given the value 9, and 157.5 to 202.5, that is the south. South is given the 9, okay, and 202.5 to 247.5, that is the southwest. Okay, southwest is given the value of 10, it is most suitable, sorry, and 247.5, that is west, and west is given the value of 5. Then after 292 point, that is the northwest, okay, it is given the value 3, and 337 point is, this is the north, this is given the value 1, okay. This has been reclassified as this, okay, click on OK, then the aspect is also reclassified. So we can see here all the layers are ready here. So the next task is to do the weighted overlay analysis. So we can do weighted overlay analysis from the spatial analysis tool in the overlay, and then in the weighted overlay. Okay, click on it. So you can see here you can add a different raster layer. So okay, let's add. Okay, let's do it serially. First one is the slope. Okay, the next one is the elevation. Okay, the next one is the mm, mm, okay, and the next one is the LLC. Okay, if you can, there is a name. Okay, let's the name. Okay, after that there is the soil moisture. This is yes, some soil moisture. This is the value. Okay, the soil moisture. And let's add other also. Other soil moisture, that is distance from the river. Okay, the class river. Okay, and then another one is the aspect. Okay, and similarly the last one is the okay, road. Okay, let's add all. So in the PDF I have given the influence. So influence here it is in percentage. So use this influence on your influence field here. For the reclassified slope, it is 30.96. Okay, even we can't give a decimal, so I'm going to round up myself. 30.96, and elevation is 26, and the LLC is 18. Soil moisture is 13, and the reclassified river is 7, and the aspect is 3, and the distance from the road is 2. Okay, so we are going to do it in going to save it. So the layer prepared will be the overlay, weighted overlay. So let's wait. So this is the weighted overlay, and by this weighted overlay, if we multiply with the land use and cover, we'll find the suitable cropland. So this is gonna be the last part of our the project, and let's do it. So for multiplication of the weighted overlay with the LLC, we are going to use the map algebra, and inside the map algebra we are going to use the raster calculator. So map algebra is also in the special analysis tool. So let's do raster calculator. Okay, so here is the weighted, and let's multiply it with uh, okay, LLC, that is not reclassified. Okay, so let's name it suitable area. Okay, let's click on OK and let's see. So we can see here the suitable area has been shown with higher value. Okay, let's change the color ramp. Okay, I think this will be suitable. Okay, the one with the green area is more suitable. So we can see here this is the hilly area, so it is not suitable, and this is the Tara area, and that is nearby the river. Okay. Okay, so this is nearby the river, so it is more suitable. We can find this like this. So this is the suitable area, and let's see the this one. We can do this. So we can also reclassify it on the different values so that we can find the area, or we can find the suitable area like this way. We can also calculate the area of the suitable area. So let's do another task in the same. Let's convert it into the KML file so that we can open it on the Google map, sorry, Google Earth. So let's add the this one. Okay, okay, suitable area. Okay, let's click on OK. So the layer has been exported as KML. So let's see. Okay, where it is. Okay, suitable area layer. Okay, let's open it on the Google Earth. So here it is. So we can see here this is a suitable area, and this is more near to a main road or highway. So you can say that this is a plain area, and you can say conclude that the data are almost good in condition. So our work has been done. So guys, here's we have successfully completed our tasks, and if you have any sort of problem, you can ask me on the comment section, or you can do mail to my mail ID that is uh, given on the description below. So see you guys on the next video. Bye.